in this talk, real-time AI-based use cases are on the rise, but they are still quite challenging to deploy in production. In this talk, we will look at the crucial role that the feature stores play in deploying AI and ML for real-time use cases. I just wanted to ask a quick question that how many of you are using any of the feature stores? Anyone? Okay, so only a very few people, they are using feature stores here, okay? So when we talk about machine learning or real time, we interact with the real-time AI models almost every day. For example, when you are watching a movie on Netflix, you are getting a recommendation for what movie to watch. Similarly, on TikTok or YouTube, you get a recommendation for the next videos. In medical diagnosis, you have image classifications. In finance, you have fraud detection and loan approval. And in manufacturing, you have predictive maintenance and visual inspection there. Most of these models, they run in real time. And as they are real time, they are more valuable and important for the business. And they become mission critical. In this talk, I will talk about that where Redis fits in there and how it helps to deploy real-time AI. So we see Redis in two different places for AI and ML. One is embeddings with vector similarity search or neural search, where you can find similar kind of images or text or things like that. And the second one, that is the focus of this talk, it is online feature stores. Now, only about a quarter of companies have deployed their their AI and ML models in production. And 85% of the models, they never make into production. And even when they are in production, they crash and burn because of performance. That's why we have MLOps. MLOps bridges the gap between what a data scientist does in a Jupyter notebook and how to take what he has developed and move it into production. Now, if you look at the data pipeline when you are deploying your AI and ML model, from scoping, gathering the data, modeling it, and doing the deployment, most of the time that is spent in gathering, collecting the data, pre-processing it, and transforming it. And that is what feature engineering essentially means there. And what we are finding in production is that feature engineering, that is becoming the bottleneck. Now, what is a feature store? Feature store simply sits between your your raw data and the model. In a sense, it is a signal that you input to your predictive model to get a result back. For example, if you are using doing credit card scoring, then it can be that the transaction was that done in a foreign country, or what is the relationship or the value compared to the previous different other transactions. You use the features to train your models, and then you also use the features to run them in production there. When you are serving your models in real time, in those cases, you want the lowest latency and the highest throughput. Also, what you want to do is that the data that you have used to train your model, you don't want it to differ too much from the data that you are using in production. That is to avoid data skews. And also, you want to reuse that data for different other models also. And that's what the feature stores, that's the capabilities that they provide you with. Now, I've been talking about real-time AI and ML. What do I mean by real-time here? Real-time means that a user is interacting with your application, or your website, and you are using raw and fresh data to give him, to run your models and serve him with the predictions there. Now, that has been a moving target for quite a for a while. About 10 years ago, it was quite fine that you ran your model about once in a day in a batch of every 24 hours. Then it moved to 2 or 3 hours a few years ago. 2 or 3 years ago, it was 200 milliseconds to 12 seconds. Now, when you move into that territory, it's not real time. But for example, if you are doing fraud detection, now, if you can run your model and get the results back in 200 milliseconds, then you are not doing fraud detection, but you are doing fraud prevention. And nowadays, when we talk about a real-time, we are talking about 50 to 200 milliseconds there, and that is end-to-end. You run you get your data, your user is interacting, you get your data, and you get the results back in that much time, and you can display that to the user in that much time. For example, like AT&T, they do that for their fraud detection in about 50 milliseconds using Redis. Ekata, they provide a risk transaction API, and again, they serve that in about 50 milliseconds there. Now, where is all that time spent if we are doing it end-to-end? So it compromises of the time you are spending in the network. That can be from 1 millisecond to 10 milliseconds. It can be in the application pipeline where you are doing some of your business logic there. You are getting your data from the feature store, and then you are running your model for the scoring there. Now, what you ideally want is that your feature store that serves your data in about, ideally, in less than 10 seconds, 10 milliseconds, but ideally in less than 1 millisecond there, so that you achieve your 50 to 200 millisecond latency there, and you have more time to run your models there. Now, if you look at a feature store, you are getting your raw data. You are getting your data from two different sources. One is the fresh data from streaming sources, and you are using Redis, Kafka, or Kinesis to get that data and put it into your feature store. The other one, you are getting it from your data warehouse, and you are storing it in your feature store. And then you are using the same data to train your models and from the feature store, and then you are also using the same model for your real-time AI. And the time that you are spending, it depends what technologies you have chosen. For example, to run your model, are you using hardware acceleration? Are you using GPUs? For your feature store, is it written in Java? Is it written in Python? Is it written in Golang? Because all of that impacts the latency of how quickly you can serve your model there. Okay? And now what we are seeing is that for online feature store, Redis is being used in most of the use cases there. And there are a lot of references there that where people are using Redis as an online storage engine for the feature store. And what the main reason for that is benchmarks, benchmarks, benchmarks. There are a lot of technologies out there that people have used for their storage engine. There is DynamoDB, Google provides their data store, there is Cassandra there. But like Uber, they did a benchmark, and in their benchmark, they found that Redis is the most cost effective for their, compared to Cassandra, to serve their features there. And they use it to handle the restaurants for Uber Eats. Feast, they provide a feature store developed by Gojek, and they benchmark Redis against AWS DynamoDB. They benchmarked it against Google Data Store, and they found that Redis is the most cost-effective and most performant feature store, and is providing for the P99. That is, out of 100 requests, 99 of them are served in less than 1.5 milliseconds there. Then you have Tecton. Again, they provide a commercial feature store. They found that Redis Enterprise, that is 3 times faster and 14 times less expensive than DynamoDB there. Now, if you look at DoDash, again, they did a comparison, and there also, Redis was the most cost efficient and highest throughput and low latency storage engine. And you will have the slides available, all the references, they are available if you want to go and look into more detail, how they did their benchmarks with how many features and how much load did they do there. Now, Redis is fast. There is no magic there. There are a few reasons that Redis is that fast. First of all, Redis is an in-memory storage engine. Everything is served from memory, so you are taking the disk out, and you are reducing your latency there. It provides extremely efficient data structures to store your data. Then it's written in C, so it provides you with consistent performance all across. So if you are getting 1 millisecond, there will not be ups and downs. You will get flat 1 millisecond latency for reading your data from Redis there. And another most important thing is that Redis, it is a data structure server. It provides you with different data structures to fit into your model. Like DoDash, when they were developing their feature store, initially they were using Redis strings to store their features. When they changed it to Redis hashes, which is just like a dictionary in Python or a hash in Java, they reduced the time, they reduced the latency to about 40%. They reduced the memory footprint, and also they reduced the CPU utilization and decrease the cost by about 5 times there. So you have a lot of flexibility when you're designing your feature store with Redis. How do you want to use it? What different data structures you want to use there? Now, Redis comes in 2 different tiers. You can get the open source tier if you want to deploy it on-prem yourself. Open source is freely available. It provides you all the core different data types. It provides you with low latency. It provides you with high throughput, and it also provides you with persistence there. We have benchmarked Redis up to 200 million operations per second there. But when you are moving into production, you need a lot more things than that. So we also provide Redis Enterprise as a service, and also on as a service, as database, as a service on all the 3 major clouds. And also we provide Redis as to deploy on-prem there. And with Redis Enterprise, you can deploy up to 5.9 availability there, which is mainframe class availability. You can deploy across multiple data centers for global applications. It provides you with multi-layer security, integration with LDAP, integration with Active Directory, end-to-end encryption there. It provides you with built-in durability and disaster recovery there, and it's extremely easy to scale out for you. So it is a batteries included service that you can just go, register, and start utilizing it there. Also, if you have terabytes of data, Redis Enterprise also gives you the ability to use Flash as an extension of RAM. That gives you about 80% of the cost savings. With Redis on Flash, you keep about your hot data in RAM, which is served with some millisecond latency, and the cold data that is on Flash, that still can be served in a single-digit millisecond latency. So you are saving about 80% of the cost there, and it will scale to terabytes of data for you. Now, in Feature Store, DoDash, they started the Feature Store trend, and initially they had an online store, but then they also have an offline store where they get the data from the warehouse, and they are using Snowflake for that, and for their online store, they are using Redis. The offline store, you have a lot of other different options there. But the main point about the offline store is that you have large amounts of data. It's like your data warehouse. You train your model there, and then you move those features that are relevant for production to the online store and serve those features for your models in real time from there. And you have multiple options available there for training and batch for offline feature store. Like you have Amazon Redshift, you can use Google BigQuery, you can use Snowflake there. And for online feature store, you can use Redis there for that. Now, just a few references that are using Redis as a feature store. Uber, in ride-hailing, Uber and Gojek, they are using Redis as a feature store. iFood, that is a Latin American company in Brazil, does food delivery, has about 80% of the market. They are using Redis. A lot of banks for fraud detection, they are using Redis as a feature store. And on the other side, a lot of online companies, they are a lot of organizations, they are providing feature stores as a product or as an online feature store, and they are also using Redis, for example, Feast and Tecton there. Now, up to now, I've just talked about Redis as a feature store, but it will become clear, Redis, it has a lot more other use cases also where you can use Redis. So Redis, you can use it as it essentially is a real-time database. So you can use Redis for your session store. You can use it for your content caching. You can use it for high-speed transactions. We talked about that, okay, you are getting your streaming data from your logs or from your user clicks. You can use Redis as your messaging system for that. You can use Redis for your jobs and queue management there also. Redis can also be used for real-time analytics. It can be used for location-based services and searching and secondary indexes. There are modules available. If you want to have connected data, you can also use Redis as a graph database there. So feature store, that's just one use case for Redis there. Now, if you want to consume Redis, Redis is available as a managed service on on AWS, on Google, and also on Azure. If you want to deploy it on-prem, you can download the software and deploy it on virtual machines or bare metal for on-prem deployment. And you can also deploy it in Kubernetes. So all the bases, they are covered for for different deployment models there. Now, if you want to go a little bit further, on this slide, there is a Colab tutorial available where it shows that how you can set up your online feature store using Feast and Redis. There are step-by-step instructions available. You can click on the link and it will walk you through step-by-step on how to do that. If you want to learn more about Redis, there is a developer portal available. You can go there. There is a Redis University that has free running courses available there. There is a Redis Launchpad where the community, there are multiple projects for different use cases available, and you can also get Redis certification there. You also have those cards on the seats. If you scratch them, there are prizes. The booth is just behind you. If you just go there, scratch the cards, and you will win something there, and you can get it from there. And if you have any questions, or if you you can either ask me now, or you can come to the stand and ask any of those questions there. Thank you very much. So.